Okay, today's lesson is 5-1A. The A is because it is 5-1 in your book, but we already did a lesson on rates and unit rates, and I wanted to make sure that we kind of separated this lesson into two parts because it's a lot to make it all into one. So some of this information you already had from the previous lesson. So this first part we aren't going to do. And we also aren't going to do parts later. So what I want to do right now, though, is I want to talk about finding a rate from a ratio table. We talked a little bit about this on your activity that we did a couple times when we did the bounce back activity. There was a ratio table, and we've talked a little bit about ratio tables. But you can use a ratio table to also determine what your rate is going to be, your unit rate is going to be. So and again, I just want to make sure that you know about it, and we officially put it there because we really didn't talk a ton about it. But when you find a rate from a ratio table, it shows the cost of all the different in this case, amount of square feet of turf that they purchase. So it gives you that relationship in a rate, or in ratio, well, it is a rate. So 25 square feet costs $100, 100 square feet costs $400, 400 costs $1,600, 1,600 costs $6,400. I don't normally do ratio tables to calculate unit rate. I use ratio tables later on when we're determining if it's a proportional relationship or not. But you can do this by looking at, okay, I have 25, and if I multiply that by 4, and then I have 100, and I multiply that by 4, and 400, and I multiply that by 4, every time you multiply by 4, and at the bottom, if you do that same thing, you can calculate your unit rate, because you're doing 4, 4, 4, 4, 4, that means your cost is going to be 4 over 1, okay, because we're talking about a unit rate. So it's just one way of using it. Like I said, I've never really used it to determine unit rate, but we use ratio tables a lot later on in this chapter, so I thought this was an interesting method to look at, just to mention. Okay, so then, let's see. I'd like you, since they did this, I'd like you to try number 3. How would you calculate or find the unit rate of number 3? What would you do? So pause your computer and do that quickly. Okay, so you have time in seconds and distance in miles. So it says the ratio table shows the distance that the International Space Station travels while orbiting Earth. Find the speed in miles per second. So what you're going to do is you're going to say, okay, what did I do to 3 to get it to be 6? What did I do to 6 to get it to be 9? What did I do to 9 to get it to be 12? And what did I do every time? I multiplied it by 2. Every single time. By 2, by 2. Okay? So down here, do I do the same thing? Do I multiply every time by 2? I do. I do every single time. So therefore then your unit rate is 2 miles in 1 second. Okay, like I said, it's just another method. It's not something I've ever done, but I thought it would be nice for you to see. Okay, so this is really what I want to talk to you about, because this is the section that I thought if we put this, and I'm erasing things I don't want to erase. If I put this in, I don't want to do that. If I put this in all in one chapter, it's too much. So what we're doing is we're going to look today at complex fractions. A complex fraction has at least one fraction in the numerator and denominator, or both. And I don't know why it's not highlighting it, but I will right now since it chose not to. And then you have to simplify those, when I'm doing it in pink, sorry. Simplify those complex fractions when finding ratios and rates. Okay? So a complex fraction, in your book, we're going to skip this next part of the graph because we're going to get to that later. in your book, they give it to you in examples of word problems, but we're going to do some that aren't word problems as well. In your book, they do them, because they're word problems, they don't show them vertically. And normally a complex fraction will look like 1/2 over 2. Okay, this is a complex fraction. A complex fraction is a fraction within a fraction. That's a complex fraction, and you have to know how to solve that. And you do that by just simplifying. And really all you're doing is dividing. So this example that they have in your book is a word problem of doing that same method. Okay, so if we go down, now this is not in your book, so you might want to write things down or make sure that you're careful when you're writing things down. A complex fraction like this, 20 over 1/2, that's a complex fraction. And you will see that on standardized tests, and you will see it a lot. They're fractions with a numerator and a denominator, or both, that are also fractions. It can be one, it can be the other, or it can be both. And then you have to simplify them. And the way to simplify them, there we go. The way to simplify them is to turn them into a horizontal fraction problem. So 1/4 divided by 4, 1/4 divided by 2, I mean, is 1/4 divided by 2, and you write it horizontally. And then you just solve like you would normally solve fractions when you're dividing fractions. So when you divide fractions, so again, like I told you guys before, fractions were never ever going to go away. You're going to see them all the time. So you have to know how to solve them. You can't just eliminate them, and you have to solve these as fractions because you need to know how to do that. So you have to then, ooh, what did I just do? Sorry. I didn't mean to do that. I hit the wrong button. So you have to write it horizontally. There it is. You have to write it horizontally. I don't know why this isn't showing up. I guess I didn't. Okay, so this would be 1/4 divided by 2. So that is really 1/4, right? You leave the first fraction the same, times, and then the reciprocal, using the multiplicative inverse property. The reciprocal of 2, which is 1/2, because 2 is really 2 over 1. So that turns into 1/2. And then you just multiply fractions. 1 times 1 is 1, 4 times 2 is 8. Okay? And the same thing here. You have that 1 divided by 1/2 becomes 1 divided by 1/2. So it becomes 1 over 1 times, and then you take the reciprocal of 1/2, and that becomes 2 over 1. And when you multiply that, 1 times 2 is 2, and 1 times 1 is 1. So that equals 2. Okay? Okay, I want you to do numbers, or letters, A and B here. So pause your computer and do the complex fraction of 2 over 2/3 and 6 over 1/3. You have to be really careful because when you look at these complex fractions, there's 2 fraction bars in it, and that can get confusing. And so the longer fraction bar is your division bar, okay, your ratio bar. So pause your computer and solve these problems, and then come back. Okay, so the first problem is 2 divided by 2/3. So you're going to turn that into 2 over 1 times, because we put a 1 under the 2, 3 over 2. And you multiply then. You take the multiplicative inverse, or the reciprocal of that second fraction. And that, I'm going to cross simplify and make my 2's 1. So then I have an answer of 3 over 1, which is 3. For B, that's 6 divided by 1/3, and that equals 6 over 1 times 3 over 1. I turned the 6 into an improper fraction by putting a 1 underneath it, and then I took the reciprocal of 1/3, okay? And then you end up with 18 over 1, which equals 18, because you can't cross simplify here, okay? There's also word problems with complex fractions. So fractions in a complex fraction represent different units. You can then find the unit rate. That's what your book kind of does. It puts these complex fractions in word problems. But I wanted to make sure that you saw them like this, because I know that you're going to have to know how to do this. So it's important that I don't want you to first see it on a standardized test or whatever and not know what you're talking about, you need to make sure that you understand that. So when the fractions of complex fractions represent different units, because we talked about that, the difference between a ratio and a rate is the difference in units. So when it's different units, you then can find the unit rate. And you're going to do that by dividing. So this first problem has 1 1/3 divided by 1/4. 1 1/3 miles divided by 1/4 hours. Josiah can jog 1 1/3 miles in 1/4 hour. Find his average speed per miles per hour. So that 1 1/3 divided by 4 is your division problem. But you need to turn that 1 1/3 into an improper fraction, a not so improper fraction. So 1 1/3 becomes 4/3. And then you're going to divide that by 1/4, which is 4/3 times 4/1. And that would then equal 16/3, because 4 times 4 is 16 and 3 times 1 is 3, which then is 5 1/3 when you simplify. So this is probably the most complex of the complex fractions that you're going to have, because first you're going to have to make it a division problem, right? And then second, you're going to have to make them all fractions, meaning no mixed numbers. Okay, and then third, you're going to have to turn it into a multiplication problem. And then fourth, you have to solve it. So this is probably the most complex of the complex fraction. And then don't forget, you also have to label it. So it's miles per hour, because that 16 on the top is miles and the bottom is or miles up here, miles per hour. So you need to make sure that you label it correctly. I don't know what that was. Okay, not quite sure. Okay, so where did my stuff go? I'm missing things. Where are they? See if it comes back to me. I typed all this stuff for you. Sorry, but it's not going to put it there. Darn it. Okay, so what I want you to do for your practice problems is I would like you to do, I'm going to have to redo it, I guess. I would like you to do number 23. Use this ratio table to calculate a unit rate. I want to make sure that you understand how to do that. And then I have two problems that aren't in your book. So you're going to need to write these down. So the first problem is 18 over 3/4. Okay. And then the second problem is 1/3 over 1/4. Okay, I want you to solve those two. And then the fourth is going to be a word problem. Okay, so I'm just going to type it in here, and I am going to, I had it all typed for you. I don't know what happened. It's the PEP Club members are making spirit buttons. They make 490 spirit buttons in 3 1/2 hours. Find the number of buttons, the PEP Club can make per hour. Okay, so now you're going to create that complex fraction problem as a rate, and then you're going to simplify to make your unit rate. Okay, so you have those four problems: number 23, then 18 over 3/4, and 1/3 over 1/4, and then this word problem to solve. Okay.